So welcome to part 2 of chapter 6. In this one we're going to talk about different prices and why they change, but the coupon bond price quotes, prices and yields are often used interchangeably. Bond traders usually quote yields rather than prices, and again, like the yield to maturity, the interest rate basically. One advantage is that the yield is independent of the face value, and then when prices are quoted in the bond market, they are always quoted per $100 face value. So they're quoted at like 98 or something like that. Zero coupon bonds, no matter what, always trade for a discount. They have to, because why in the world would you buy something and then get less when you were finished? So coupon bonds on the other hand may trade at a discount or at a premium depending on the market rate compared to the face rate. Most issuers of coupon bonds choose a coupon rate so that the bonds will initially trade at or very close to par. So when you're issuing bonds, the board of directors get together, they decide that they're going to issue bonds and how much they're going to raise from those bonds. They set all the terms, they set the interest rate, they set the payments, they set all of that. Well, from the time that they make that decision to the time that they actually issue the bonds, there may very well be a change in the market rate. And so instead of changing, you can't change all that stuff because the bond certificates have been printed and so on. So what you have to do is you change the price. So that's what happens. So the interest rate changes with the bond prices. If a bond sells at par, then that means that the face rate is exactly equal to the market rate. Therefore, the bond's coupon rate will exactly equal its yield to maturity, and any interest rates in the economy fluctuate. The yields of that investors demand will also change. And we get into this a little bit later. But one thing I want to point out is the interest rates and the bond prices always move in opposite directions. So if the interest rate goes up, the bond prices will go down. If the interest rates go down, the bond prices will go up. These are on page 157, 156 and 157 of your book. In fact, here is a table that you can use, that it's on page 157. That's kind of the summary of that. So when the bond price is greater than the face value, then it's going to sell at a premium. In other words, the coupon rate is greater than the market rate. The yield to maturity, think of that as the market rate. If it's equal, the bond price is equal to the face value, then it's going to be issued at par. So if it's $1,000, 3% bond, and if the market rate's 3%, you're going to sell it for $1,000. If the bond price is less than the face value, then it's being sold at a discount. When it's sold at a discount, the coupon rate is less than the yield to maturity. So in other words, they could get a better rate out in the market than they could from yours. So in order to entice them to buy your bond, then you discount it. That's kind of regular economics. So to sum this up, the very bottom line, when the coupon rate is greater than the market rate, then it sells at a premium. And then the last one, if the coupon rate is less than the market rate, it sells at a discount. So here's a problem. 3 30-year bonds with annual coupon payments. One bond has a 10% coupon rate, one has a 5%, and one has a 3%. The yield to maturity of each bond is 5%. What's the price of each bond? All right, so first of all, going back to that last slide that we had, the 10% coupon rate, they are paying more than what the market rate is. Market rate's 5%. So what do you think it's going to sell for? Is it going to sell at a discount or premium? So if you were able to get more out of your bond, more interest rate out of your bond, you're ending up going to pay more, because what you're going to pay is going to eventually equalize that 5%. So the 10% coupon rate is going to sell at a premium. The 5% coupon rate is exactly the same as the yield to maturity, so that will sell at par. And then the 3% is going to sell at a discount. So what you do, you just put these into your calculator. We'll start with the 10%. The N is 30 because it's annual coupon payments. N is 30. I is 5. The 5% is the yield to maturity. 5% will be the same on all of these. The only difference between these three bonds is the amount of the payment. So I is 5, N is 30, I is 5. Present value is what we're trying to find. So the payment, so the 10%, if it's a $100 bond. Oh, $100 bond. All right. So 10%, $100 bond. They're going to get $10 a year. So the payment would be $10. If it's a 5% bond, then they get $5 a year. And if it's a 3%, they get $3 per year. So that's the only part that changes. So we'll do the 10% one. So payment is 10. Future value is 100. Payments per year is 1. So when you solve for your present value, the 10% coupon should be 176.86. The 5% coupon should be 100 because the coupon rate exactly equals the yield to maturity. The 3% coupon rate, the difference there is that will sell at a discount, and that price is going to be $69.26. So check those answers. I guess they are right here. So there they are on this slide, on slide 55. All right, you can do the same thing with this one. I will give you the answers. You can try it out. 3 30-year bonds. One has 12%, one has 6%, one has 2%. Yield to maturity is 6%. So put these in, figure out what they are, and I'm going to give you the answer. So if you want to pause here, work them out, and then I'll tell you what the answer is, then that would be great. The 12% bond sells for $182.59. 6% bond sells for $100, and the 2% bond sells for $44.94. So you can pause here, and we can work out problem 13 and 14. All right, so this is this figure shows what happens to the price of the bonds as it gets closer and closer to each of the coupon or each of the interest payments. So if you look at the 0 coupon bond at the bottom, it never changes. I mean, it's going up. The longer it is, the bond price will go up, because if it's a 30-year bond, it will go up, because if you buy it at 25, why in the world would you buy it for, I mean, somebody sell it to you for what they bought it for when it was year 0. They're not going to get much money out of it. So that one doesn't really change it. It's considerably, I mean, going up, but because it doesn't spike near the coupon times, it doesn't have those little squiggly. So as the next payment from a bond grows nearer, the price of the bond increases to reflect the increasing present value of that cash flow. And then once that interest rate payment has been made, then it goes back down. So suppose you purchase a 30-year 0 coupon bond with a yield to maturity of 5% for face value of $100. The bond will initially trade, it's a 30-year 0 coupon, is going to initially trade for $23.14. That's the present value. So if the bond's yield to maturity remains at 5%, what will its price be 5 years later? Well, the deal is here, all you do is change. If the yield to maturity remains at 5%, then all you're doing is changing this formula that's here on the screen to 1.05 to the 25th, because it's 5 years later. And that obviously will make it higher price. So if you purchased the bond at $23.14 and sold it 5 years later, what would be your rate of return? Well, so we did this. The 25 years, the price would be $29.53. So to find the rate of return, well, obviously the yield to maturity didn't change, but if you purchase the bond for $23.14, that's the present value, sold it for $29.53, that's the future value, and it's 5 years later, you can do it like that. Take the future value divided by the present value to the 1/5 minus 1, that's your 5%. So that would be the return per year. I mean, it would actually be a higher return, but for 1 year, it's 5% annually. So the bond price is higher, the discount from its face value is smaller when there's less time. and the discount shrinks because there's less time. And the very bottom bullet here is important. If a bond's yield to maturity does not change, then the rate of return of an investment is equal to its yield to maturity, even if you sell the bond early. So work this one out and see what you can find out. You purchase a 20-year bond, 0 coupon, 10%, face value of $800, and that's the price you paid for it, $118.91. Yield to maturity stays at 10%. You purchase the bond at $118.91, sold it 5 years later. How much would you get, and what would your rate of return be? So you can pause it now, and I will. You can work this out, see what answers you get, and then I will give you the answer. So the answer is, for the first part, the price would be 5 years later, $191.51, and the rate of return is 10% because the yield to maturity didn't change at all. All right, we can do the same thing here. This is a very similar problem that we just had. You can work this out and I will give you the answer, so you can pause it if you want to. But 8 years later, the price would be $278.42, and the yield to maturity, the return is 5%. So you can pause now, and we can work out. Go to the other recording that has problem 19 on it. All right. So now, why do bond prices change? The deal is with the interest rate and the risk. So effect on time on bond prices is predictable, but unpredictable changes in rates also affect the prices. And so bonds with different characteristics will respond differently to changes in interest rates, and investors view long-term bonds to be riskier than short-term bonds. So consider a 10-year bond. It has coupon payments. 30-year coupon bond. Consider a 10-year coupon bond and a 30-year coupon bond, both with 10% annual coupons. By what percentage will the price of each bond change if its yield to maturity increases from 5% to 6%? So what you need to do, you need to compute the price of each bond. So you need to compute the present value. You need to compute the present value at 10%, and then, compute the present value at 5% for both of these, compute the present value at 6% for both of these, and then figure out what the change is, or what the difference is. And so both bonds, the cash flows are $100, $10 per year for $100 face value. So if we figure $100 face value, they get $10 per year because it's a 10% coupon rate. And so when you put this in your calculator, N equals 10, I equals 5, present value is what you're trying to find, payment is $10, future value is $100, and the payment per year is 1. So do that for the 10-year bond. You should get $138.61. Do the same thing, except change the N to 30 for the 30-year bond, and you should get $176.86. Now go back through that process and change the I to 6% and see the difference. So you can do that, and of course you can see the answers are here. The difference between these, the price of the 10-year changed 6.6%, the price of the 30-year changed 12.3%. So the longer it is, the riskier it is, and the more volatile the price will be. So that's something to keep in mind. Here's the evaluation of it. The 30-year bond is twice as sensitive to a change in the yield than a 10-year bond. So in fact, if we graph the price and yields of the two bonds, we can see that the line for the 30-year bond, shown in blue, is much steeper than the green line, which is the 10-year bond. So showing that it's a lot more sensitive to the changes. So here, this problem, consider a 5-year bond, 40-year annual coupon bond, both with 5% coupons. Find the difference between a 5% yield to maturity and a 6%. So work that out, and I will give you those answers. So if you want to pause it now, you can do that, and I'll give you the answers. All right, so the change in the 5-year bond ends up to be about 3.95%, and the change in a 40-year bond is 13.8%. All right, so this is on page 161 that you might want to keep this in mind. The bond characteristics, the longer term to maturity, it increases the risk. And if it has higher coupon rates, it's going to decrease the risk of these bonds. So in this problem, 2 bonds, each pay semi-annual coupons, 5 years left until maturity. One has a coupon rate of 5%, the other has a coupon rate of 10%, but both have a yield to maturity of 8%. How much will the price of each bond change if its yield to maturity decreases from 8 to 7%? Basically, you're doing the exact same thing that you did in the other one, because you want to see what the, this time, it's going to be the present value. So solve for the present value for both of these and see the difference. And I believe the answers are in here. So you can look at these as you go through these. And at the very bottom here, semi-annual rates of 4% and 3.5%. All right. So there's the answers to those, and that's in the regular one. Just obviously you see that this is in your normal slide. The evaluation is bond with a smaller coupon payments is much more sensitive to changes in interest rates. And so because the coupons are smaller relative to its par value, larger fraction of its cash flows are received later. So smaller coupons are more risky. So later cash flows are affected more greatly by changes in interest rates. So compared to the 10% coupon rate, the effect of the interest change is greater for the cash flows of the 5% bond. Here's another problem. You can do the same thing here. You can pause it. So read through this, pause it, and I will tell you the answer. So for the first one with the 4% coupon rate, that's going to be, I believe, 4.48%. And the one with the 12% coupon is 3.9%. All right, so you can pause here and we can work through problem 20. All right, so now we get into why bond prices change. And bond prices are subject to effects of both passage of time and changes in the interest rates. And prices converge to the face value due to the time of the effect, time effect, but move up and down because of changes in yields. At the end, their price is equal to their maturity value, which would obviously make sense. This is on page 163 if you want to look at that. As you see, in actuality, in panel A, the bond over time, bond yield to maturity fluctuates depending on the economy, etc. And then in panel B, the price over time, you can see how it increases, although it's fluctuating. The actual bond price is fluctuating throughout that time, but generally they are increasing up to the maturity, the 100%. These are percentage over on the left-hand side. All right, with corporate bonds, credit risk, U.S. Treasury securities are widely regarded to be risk-free. So when we're talking about the risk-free rate, we're talking about the rate of U.S. Treasury securities, whether they are bills or notes or bonds. Credit risk is the risk of default, so that the bond's cash flows are not known with certainty. Anytime you get outside of the U.S. Treasury securities, when you're looking at corporate bonds, then you're going to have a higher default risk, because that's just the way it is. And so you need the corporations with higher default risk will need to pay higher coupon bonds to attract their buyers. The difference between these two, between the U.S. The risk-free rate and the corporate rate, is the credit spread. And Page 164, table 6.5 will give you an idea on that one also. All right, so the corporate bond yields. These, the yield to maturity is not equal to the expected return. The yield to maturity of a defaultable bond is based on promised payments. The expected return is based on expected payments. So they may not be equal. A higher yield to maturity does not necessarily imply that a bond's expected return is higher. So these may be different. A higher risk, they promise to pay these interest payments, which is a higher yield to maturity, but that doesn't necessarily mean they're actually going to happen. It's based on risk. Oops. Bond ratings. Several companies rate the credit worthiness of the bonds, and two best known ones are the Standard & Poor's and Moody's, and this helps us assess how creditworthy these companies are. So they will have a credit rating. And here are these, depending on Moody's or Standard & Poor's. So Moody's is on the left, Standard & Poor's on the right. And this is on page 167. So these are considered, this group here is considered low default risks. Obviously, AAA is the top one, judged to be the best quality. There's only 5 public firms that are in there, and I don't know who they are. This is this bottom half, and these are more of the junk bonds, the speculative bonds, the higher risk of default. So they have a promise to pay of a higher yield to maturity, but that doesn't mean that the expected amount is going to be the same, because it's much higher risk. The bond ratings, we've already talked about this. Investment grade bonds were the first group, and then the speculative bonds were the second group. Very high risk on that second group. And the rating depends on the risk of bankruptcy and if those bonds are secured. If they're not secured, then the risk even goes higher. So corporate bonds have their own yield curves. Plot a yield curve for corporate bonds just as we can for treasuries, and the difference between those yield curves is called the credit spread. And so this is on page 167. So you'll see the blue line is the treasury yield. That's the risk-free yield. And then the other ones, the next one up is the AA, the next one up is the BBB, and the highest one is B. And they don't even show the other ones. But the difference between those lines and the blue line, the bottom line, is the credit spread. All right, so let's do an example here. Your firm has a credit rating of A. You notice that the credit spread for 10-year maturity debt is 90 basis point, or 0.9. Your firm's 10-year debt has a coupon rate of 5%. You see that the new 10-year Treasury notes are being issued at par with a coupon rate of 4.5%. So what should the price of your outstanding 10-year bonds be? All right, this 0.9 actually came back from page 167 from that figure. So basically what you do with this 0.9%, you have to add that to the Treasury note coupon rate. That 0.9% is your credit spread. You just add it, which ends up to be a 5.4% yield to maturity. So that's all that means. When there is the credit spread is 90 basis points or 0.9, then you just add that to the Treasury, and that will be your yield to maturity. So let's, the cash flows on your bonds then are $5 per year for every $100 face value, $2.50 every 6 months. You have a 5.4 yield to maturity, so that's your I, and the price of your bonds. So using your calculator, these are 20-year bonds. No, these are 10-year bonds. Sorry, 10-year bonds, semi-annual payments. I'm going to go back to the one before. No, one more before. All right, 10-year bond. So when you're putting this into your calculator, coupon rate of 5%, semi-annual payments. So N equals 20, I equals 5.4. Present value is what we're trying to find. Payments are $2.50. per $100. Future value is 100. Payments per year are 2. So when you solve for your present value, you should get $96.94. As you can see right there. They did it that way. We did it in our calculator. All right, so now I want to do the same thing with this one. If your firm has a AAA credit rating and the credit spread is 60 points or 0.6, your firm's 10-year debt has a coupon rate of 4%. 10-year treasury notes are issued at par 3.65. So what's the price of your outstanding 10-year bonds? So do that and pause here, work it out, and see if you get the same answer I do. My answer that I got was $97.98. So pause here, do problems 25 and 26. Actually, we are at the end of the chapter. So there's a chapter quiz that you can take for yourself and the second part of the chapter quiz. And that's it. Have a great day, and I will see you soon.